So we're just going to go on and we're going to do a little bit of summary of direct and partial variation. So I'm going to just give you a really quick kind of summary of what the difference between these two are. So if we're going to look at even these two, right? This is what we call a direct variation. And that's because any change in x is directly coming from the slope. This is considered a partial variation. And that's because you have a slope, you have some change coming from the slope, but you also have that initial 100, which kind of skews the data. So what happens here is that you have not a constant rate of change, or what's looking like it's not a constant rate of change. It's looking like when you divide the x and the y, they're not constant, or the y and the x, they're not constant. Okay, so a direct variation has 0, 0 as an ordered pair. That means that at some point, ordered pair on the table of values. That means at some point that graph crosses through the origin. The initial value is 0. Sorry guys, I'm really apologetic. I don't know what's in my throat. The initial value is 0. So the graph itself, and I said this already, graph passes through and the equation for this often looks like y equals mx, where y represents the y value and m is the slope. Okay, so m represents slope. We talked about that yesterday, or this morning, or in our last lesson, sorry. Right, so partial variation, on the other hand, 0, 0 actually doesn't exist on that graph. So if you look back here, right, there's no 0, 0 value. If this was to keep going, you would never cross the origin. So 0, 0 is not an ordered pair. Right? The initial value or the value at which this crosses through the y-intercept is some number b. Some number b. And b is important. So the graph, when it intercepts with the y-axis, right, which is why we call it the y-intercept, because this is the one it's meeting the y-axis. It's meeting here. When it intercepts with the y-axis, the graph passes through zero and b. So the equation looks like y equals mx plus that initial cross through, because it seems to be shifted up a little bit. Okay? So if we're given a relationship that is a direct variation, it's not going to have that b value. So we can just find out what the slope is by saying, okay, let's do y divided by x. So we can determine the constant of the variation. You can determine the constant. Or the slope by doing y divided by x. So in this situation, we can just do 18 divided by 6 equals 3, right? So this is going to go up by 3 each time. So determine the equation of the relation. It's just going to be y equals 3x. So let's just complete this table. Let's just go in and say, all right, y is equal to 3x, and x is 4. Y is equal to 3 times 4, 12, 15. 7 times 3 is 21. 8 times 3 is 24, 27. Another way we could figure this out, this seems to be increasing by 3 each time. You're just adding 3. Okay? So we completed the table. If y varies directly as x, which is the same thing as saying this is a direct variation, and y is 36 and x is 9, determine the value of y when x is 4. So first things first, let's figure out the constant. Or the slope. So I know my slope is y over x. So I'm going to do, what's my y value? 36 divided by x, which was 9. So I know my slope is 3, right? So if my slope is 3, right, because I'm doing my constant, so we won't even do, we'll say constant, because that might confuse some people. My constant is 3. That means that my slope notation is y equals 3x. So let's just do y equals 3 times 4 equals 12. Okay? Now this is where it starts to get a little bit tricky because now we're using word problems. So it says Melissa works in a store and earns 8% commission on her sales. And on top of that, she makes a $350 a week salary. So is this a direct or a partial variation? It's a partial variation. And that is because she'll never make $0, right? She'll always at least make $350 even if she sells nothing the entire week, right? It's a partial variation because the graph itself will start at, even if she makes no sales, will start at 0 and 350. Because even if she makes no sales, she'll at least make $350 a week. So let's figure out the equation for the situation. So if I know it's 0 and 350, I know it's going to be 350 at the end. Y equals. Let's define our variables first. Oops, sorry. Let's just go in and define our variables. So I'm going to say y equals the amount of money she makes, money made per week. X is going to be the sales that she makes, so the dollars in sales that she makes, right? And then my B value is going to be her weekly salary. I know that my B is going to be 350, so I'm going to add that at the end. Y is what I'm looking for. X is what my weekly sales are going to be. How do I know how much money, how much is going to go up by every time she makes a sale? It says she earns some amount of commission on each of her sales. 8%, right? So she earns 8% of commission on each of her sales. So we're going to put the 8% in front of the X. It's going to go up by 8% every time she makes a sale. So I have Y equals 0.08x plus 350. That's my equation, right? So if that's my equation, I'm just going to make this into a color that everyone can see. If that's my equation, right, so I'm going to write Y equals 0.08x plus 350. If she makes $5,000 worth of furniture sales, right, how much will she earn? So I know Y is how much she's making, so that's going to be empty. 0.08. X represents how much money she made in sales. So I'm going to plug in the 5,000 plus 350. So right off the bat, I'm going to go in and I'm going to say, okay, what's 0.08? So 8% of 5,000 is going to be 400, right? So she'll make $400 in commission plus the $350 she's making regardless. So altogether, she'll have made $750 that week. So Y will equal 750. Therefore, Melissa will make $750 this week. Or that week, or whatever you want to write. Okay? So, what we're going to do is we're actually going to be doing a little bit